I'm going to go ahead and turn on the mic and we'll go ahead and start. So I want to thank everyone for joining us today for today's session, SUSE worker nodes on Amazon EKS. My name's David Rocha. I'm a SUSE public cloud architect, and what I do is I work with the Alliance team from AWS, ensuring that SUSE is represented in the AWS cloud platform. Jay, if you want to.
Sure. Turn my mic on. So I'm Jay McConnell. I work in the Partner Solutions Architecture team, specifically on building quick starts. So I work quite closely with SUSE on building out a AWS quick start for a cloud application platform that uses EKS. So I kind of got a lot of the knowledge through that process.
Yeah, so today we're going to cover what the SUSE and AWS Alliance, what we've been up to, what we've been doing, and some new releases. Before we jump into Amazon EKS, we really need to level set what are containers and what are the benefits. So we're going to briefly touch on that. And we're also going to describe why customers are choosing Amazon EKS and discuss the SUSE Worker Node Initiative, what are we doing to make SUSE a worker node within the Amazon EKS environment. So if you look at the milestones, I mean, we've been working with AWS for almost 10 years. We were the first enterprise Linux distribution available on AWS, and we do have a public cloud engineering team that focuses on bringing those SUSE solutions onto the AWS. So if there's driver updates, kernel updates, anything that is required, we do have a public engineering team that's focused on that. And we have, these are just a few of the milestones. I mean, there's no way that we can put everything that we've done and accomplished together. And if you look at 2018, we've had some pretty cool initiatives. There's been a lot of introduction for new instance types in AWS, and of course, SUSE is able to run on those platforms. We also have the SAP HANA Quick Start features. So Quick Starts are a way to programmatically deploy workloads into AWS and run it in a best practice fashion, right? So these are approved best practice deployments. And we have that within the SAP environment. We also have a SUSE Cloud Application Platform that is available on AWS EKS. And that's all done this past 2018.
Briefly, the quick starts, is it just documentation or does
it includes both. It's documentation and it does include CloudFormation templates. I don't know if you want to touch on that, Jay?
Yeah. So both documentation on how you would deploy a particular workload in a best practice kind of environment on AWS, as well as an automated deployment of that. So, you know, the idea behind them is that they're gold standard, they're production ready, and they take advantage of all of the benefits of AWS Cloud.
And I said we've done a lot of new innovation. In fact, during the SUSECON, we've actually had two announcements. One is SUSE Linux is available on Amazon EC2A1 instances. These are the ARM processors, and they're really leveraged for scale-out workloads. So if you have a scale-out workload and you're looking for a cost savings, you know, the A1 instances are perfect. And of course, the SUSE Cloud Application Platform. What that SUSE Cloud Application Platform is, it's really bringing a cloud-native development platform to Kubernetes. So we're allowing customers to quickly deploy containers and leveraging the orchestration of Kubernetes. And that quick start is actually running on, it's available. It was released yesterday, I believe. It was pushed out yesterday. So you can actually deploy, I'm going to call it CAP, SUSE CAP, as a quick start in a best practice methodology across 3 different availability zones. So it's pretty cool. It's documented, and it is, as Jay said, a CloudFormation template. So SUSE and AWS are really dedicated to the success of our customers. We have, as I said, over 9 years of joint engineering. A lot of the solutions that we bring to market are made available in the public cloud. And we work closely with the AWS team. They let us know what's upcoming, and we ensure that we align our engineering resources just to make the availability for our customers, because we do have a lot of that demand. We're also a trusted mission-critical enterprise distribution, right? So the fact that you're running on AWS is a world-class platform, but we still maintain our standards. So whatever is best for that distribution with on-premise, we follow the same principles and practice on the public cloud. We really don't create or perform shortcuts. I'm going to go ahead and shut that. Yeah, you got it. It's stuck. No, it's all right. And we have seamless Linux support from AWS. So AWS support engineers, you can contact them, and they are trained on SUSE solutions. So it's not a disconnected support experience. You do have that ability to not only leverage SUSE support for SLES or whatever other products we have, but you can also leverage AWS. So what are containers? And we're going to briefly cover this before we dive into Amazon EKS. So containers are really a set of processes that are run isolated on a Linux host. What a container is you're providing a developer or an application the ability to run on binaries, packages, independent. So there's no more application dependency, or there's no more dependencies on that host system. So if you're running a container and you're running your application on that, previously, like if I developed an application on my laptop or on a test environment, I had specific package versions, and I was tied to that. And if I pushed it out across my platform, my infrastructure team pushed that application out, I had to deal with it as a developer. I had to deal with dependencies. I had to make sure that my test environment was running the same package versions as what was available in production. And sometimes a lot of effort was made to maintain that compatibility or that standardization. And what containers have done is they've packaged. You're allowed to create those images with those packages self-contained. So you're no longer relying on that host system to provide that package. It's really just the container. And if you look at what this does, as opposed to, if you were to compare it to virtualization versus a container, a VM, you're still able to kind of have density across a virtualized environment, but you're running a guest OS on that VM. And the hypervisor is interfacing with the VM to kind of provide the resources needed to run. With a container, you're no longer running that guest OS. It's really just the packages and libraries that are required to run that container. And you can really increase the density across that system by leveraging the containers. And as I said, you're really eliminating those dependencies. So I can have one container that requires a specific Python version and another container that has another one on the same system without any issues. But containers still need to be managed, right? It doesn't solve the problem as far as orchestration and management. You can have that container sprawl. If you were to just set up these disjointed systems and deploy containers, you would be in charge, or the IT or developer would be in charge of managing that infrastructure. How are you going to scale it out? How are you going to define these application endpoints? All that has to be managed and maintained. And this is really where Kubernetes comes involved. It provides that container-centric management environment. It orchestrates the compute required to run the containers, the networking, the storage, and it really provides that infrastructure on behalf of those containers. But setting up Kubernetes really isn't easy. There's a lot of effort and knowledge that are required into deploying, setting up, configuring, and updating. And this is really where Amazon EKS comes involved.
Cool. Thanks, David. So, apologies in advance if my speaking tone isn't great, monotonous, a little bit nervous. I'm not a seasoned public speaker, so hopefully the content makes up a bit for it. So, the way AWS decides what to build next is we have a process called working backwards. So we'll start with customers asking us for stuff, and then we'll work backwards from that until we come up with a service offering. And that's really what happened with EKS. A large volume of customers were running Kubernetes on EC2, and those customers came to us and they were saying things like, running Kubernetes isn't trivial, and it's undifferentiated. We could spend our cycles doing things that bring more value to our business. There's a lot of nuances in how it's configured and how it's deployed. Managing the etcd data store can be really hard, especially in a high availability scenario. And then the master nodes also need to be configured. So essentially, the customers were saying, can you run it for us? So we built EKS. Perhaps a good way to look at how we turn that feedback into a service is to look at the service's tenets. So the first tenet is EKS is a platform for enterprises to run production-grade workloads. So we looked at how customers were running Kubernetes in production already, and we took a decision on which parts to automate, which parts to abstract behind the managed service, and which parts to leave flexibility for the customers. EKS provides a native and upstream Kubernetes experience. So a lot of customers said to us, while it's hard managing all of this infrastructure and the control plane, we like the fact that it's a native upstream experience, that our engineers are contributing to the Kubernetes project, and we want to retain that. So we don't want any secret sauce added to the existing Kubernetes offering. And the third tenet is that customers are not forced to use additional AWS services. So EKS can be used standalone, you can be a full Kubernetes shop, and if you choose to, there are integrations to allow you to consume other AWS services, but it's in no way required.
Jay, are we supposed to see these?
No.
Okay.
I didn't have a slide for them.
Oh, okay.
There goes the mic. Let's click that back on. Okay, so have a look at how EKS was built. So as I said, the complexity of standing up the control plane has been vastly simplified. You don't run it in your account. The EKS service team runs it in a set of, they're running on AWS. We use our own building blocks when designing a new service. So they're running it in their own production AWS accounts. The control plane runs there. Worker nodes run in the customer account. So a customer can choose their desired operating system, they can choose a configuration, they can harden that worker node as they see fit. And you can continue to use the existing tooling. So kubectl, all of the open source tooling that's out there works pretty much as is. I wasn't expecting that to happen. So how you configure EKS today is basically this process. So the control plane's managed, you make an API call to AWS, we stand up a control plane for you, and that's a highly available control plane, and that lives in the service team account. You get an endpoint returned from that API call. That endpoint is then used to make Kubernetes API calls to. You set up a worker node. The worker node needs the standard stuff you need on a Kubernetes worker node, the kubelet, whatever other network plugins you want to have running. We provide one as well, which I'll go into in a bit. And then the authentication mechanism. So we use AWS IAM for authentication. So there's a little plugin that was originally developed by Heptio and has now been taken over by a Kubernetes SIG that provides IAM authentication for Kubernetes. So all of the things that might keep you up at night. Is etcd being monitored? Is it being backed up? Is my security group configuration for my masters done properly? Am I allowing traffic in where I shouldn't be allowing traffic in? Did we deploy the control plane in a way that's in accordance with best practices on AWS? All of that has been abstracted away. You just have the one API call, and all of that kind of gets taken care for you. So if we have a look a little bit deeper, the VPC on the right is what happens behind the scenes in the service team account. So when you make that API call, that's the infrastructure that's been set up. And obviously the control plane's vastly simplified there. Most of the communication from the worker nodes happens outbound to the Kubernetes APIs. So those happen via a network load balancer. One of the nice things about a network load balancer on AWS is you get a set of static IP addresses. Even though it's scalable, you have kind of well-defined addresses if you need to firewall around those. So outbound communication happens either via a public interface, so these worker nodes could be sitting publicly, and that communication could happen over the internet, or you can do it via a private link, which would keep that all within your VPC, and basically a virtual router's tacked onto the end of your customer VPC on this side. So those would happen privately. And you can choose to mix and match. So you could have your CLI tools running over the internet, connecting to Kubernetes publicly, and then have your worker nodes using the internal interface, or lock access to the API down entirely. Some of the communications, though, require inbound connections from the control plane. So when you fetch logs from pods or containers, or where you SSH into a container to do troubleshooting. And for that, the EKS control plane, when you provide that create call, you specify a VPC in your account that you're going to place your worker nodes into. And the control plane places an ENI into your VPC that bridges the control plane's VPC through. So those outbound connections into your VPC can happen without you needing to expose anything publicly. So in terms of how we configure the masters, previously with something like COPS, or if you were standing it up yourself, you would have fairly complex choice on what instance types, how many of them, how do you spread the load across availability zones. You need to deal with all of that. So the service abstracts that away, and you just make that one call, and we'll scale that as needed behind the scenes. So without any outage, if you've got a really busy cluster, and it's fairly intelligent, it'll look at how you're busy, so the type of workload that's running there, it'll scale the backend master and etcd nodes as needed. So the cluster stays performant, and I think we're kind of rating EKS for up to 2,000 nodes. So the idea is that you'd be able to scale up to a really busy 2,000 node cluster without having to worry, and all of the scaling of that infrastructure happens behind the scenes. It's also fairly important to note that if you're standing up Kubernetes yourself, doing that scaling and changing instance types is actually really hard. So what a lot of customers ended up doing is they would actually bring down their whole control plane, stand up a new one with the new instance types, and then have to migrate their data across. So this really solves that problem for customers. And yeah, this slide kind of is a very poor representation of that. So scale up in a transparent manner. You know, that's across availability zones. EKS now has support for regions with only 2 availability zones. So depending on the region, either 3 or 2 availability zones. That scaling will happen behind the scenes. If there's an outage, you know, and whole availability zone goes down, your cluster remains available. If there's security patching that needs to be done on the nodes, that's done in a rolling fashion, so your cluster stays available through that as well. So to the title of the talk, how do we actually provision these worker nodes? So there's a couple of options, and we're providing decomposable assets that you could use to do this. So the easiest entry point is the official AMIs. So we have Amazon Linux AMIs. You can fire those up really easily. The service team provides CloudFormation templates that will bootstrap them to just automatically join to your cluster. And the process for building those AMIs has been open sourced. So it's a bunch of Packer scripts. Those Packer scripts are made available on GitHub, and you can you know, insert your own flavor of Linux there. So SUSE Linux with a little bit of modification to the scripts to handle different package managers and that kind of things, different dependencies that you might require. But the whole process for building that AMI is open sourced. In the AMI, like the kind of needed components is the kubelet. So that's the part that's going to communicate back with the API, with the Kubernetes API. The IAM authentication helper, so it's a little plugin that helps you get IAM authentication going. Docker or another container runtime. And then, as David mentioned, we also have the quick start now. So we don't have SLES or OpenSUSE AMIs available today. We're hoping that they come pretty soon. But with the quick start, what we've done is we've taken those Packer scripts, we've modified them as needed, and you can actually use that to build your worker nodes. There were a couple of gotchas when we went through that. One of them is around how networking is done. So the networking plugin adds additional IPs, and I'll go into some detail in that in a minute. But SLES had some great boot up scripts, or some scripts that interfaced with IFUp that would automatically start adding all the additional IPs to the host node. And we needed those IPs attached to the container, not to the host. So we had to disable that from the standard SLES AMI. And then if you look at Cloud Application Platform specifically, it has a component called Diego Cells, which essentially runs containers in containers. And to enable that, there were some kernel flags that needed to be changed. So we've kind of automated that all out. That's available as a component of the quick start. So if you wanted to run SLES with EKS today, you could use those templates to run it, and then shortly there'll be an AMI that makes that even easier to run.
Hey, could you distinguish one time, because I thought they were the same, distinguish between the AMI and the quick start?
So the quick start is a lot of automation on top of the AMI. The AMI by itself will provide you with a worker node. So it's an image that has all of the tools needed for a node to be able to connect to EKS. Joining that together, you know, am I going to stand up a single instance? Am I going to make an auto-scaling group? What are the properties of that auto-scaling group? All of that is in the quick start in a best practice fashion. So we've kind of been quite prescriptive in the quick start about what we think is best practice, both from the SUSE side and from AWS side. Whereas with the AMI, you can choose how you want to do it, right? So you get a lot more flexibility, but there's a bit more heavy lifting. So let's have a look at how the networking is done. Typically, Kubernetes networking is done with an overlay network. It's the most common pattern. So there'll be IP traffic tunneled in some way, and there'll be a private address space. The default plugin that comes with EKS doesn't work like that. So I mean, the concept of the AWS VPC is a software-defined network already. And we felt that why add another layer on top of that when we have all of these great controls that customers are already used to using? A couple of the things that guided the creation of this plugin was that we wanted high throughput and availability, low latency, and minimal jitter. Very comparable to what we'd get from traditional EC2 networking. So adding additional layers there would have definitely impacted that. The next was making network operation simple and secure. So the idea that customers could apply existing VPC networking and security best practices was very appealing. We don't have this extra layer to start troubleshooting networking issues. We've got VPC flow logs, which essentially is packet capturing that you can just turn on with the flick of a switch on VPC networking. That's great to be able to dive into networking problems within your container-based applications. Routing policies on VPC, so traffic engineering, there's a lot of good practices around that already. And to be able to use the construct of security groups so that you can enforce isolation between containers and different components on your Kubernetes cluster, especially useful if you have regulatory requirements. So kind of how this works. I'm not sure how familiar everybody is with Kubernetes. So there's a concept of a daemon set, which is essentially a set of containers that Kubernetes will ensure that there is one running on each and every node. The network plugin is deployed as a Kubernetes application, and it's deployed as a daemon set. So as soon as a new worker node joins, Kubernetes will go, hey, you need this application running on it, and it'll put the network plugin onto each and every instance. We call it IPAMD, so Local IP Address Manager, and essentially what that little component does is it reaches out. Every time a new container is started, it'll reach out to the EC2 APIs and it'll say, do we have any available addresses on the interfaces that we've already got attached to this instance? If so, let's just pick one of the unused ones and we'll attach it to this instance and then route the address through to the container directly. If there aren't any available ones, then it'll actually attach an additional elastic network interface and start consuming addresses from there. And this is doing that. So if you can imagine the pods in a traditional network, they would, in a traditional Kubernetes networking architecture, these would get private addresses that are completely segmented from the outer network. So if you were sitting on the network that Kubernetes was running on without additional IP tables rules, you can't actually get to these containers. Whereas with the model that we have, as long as you have rights via the security group and you're able to get into that VPC, you're able to connect to those containers directly. As you can see there, the IP addresses are mapped from that network interface directly to the containers. And the next component that is slightly different with EKS out of the box to a self-managed cluster is how we do authentication. Again, it's completely upstream Kubernetes, so these are all provided as open source components. This component is not swap-outable today. The CNI, if you prefer to use a different networking model, you can, but this is actually baked in quite deeply. So this component is not swap-outable as such. And basically what it does is we have a service called Security Token Service that takes a set of credentials that are passed to the API and convert those into a token. And that token can later be used to verify somebody's identity. So the way we use it in the Kubernetes context is how do I describe this nice and easy? Anything that's making a request, whether it be machine or human on the CLI, The first thing that will happen, and this is via a little plugin that gets installed both on the worker nodes, and if you're running the CLI, you need to install the plugin. The plugin essentially intercepts the initial API call to Kubernetes. It'll go out and make that request to get a token from AWS, and it'll use your default credential chain. So if you're familiar with the AWS CLI, you will have configured it with a set of credentials. On the command line, it'll do the same thing. In the case of worker nodes, it'll use your instance profile, so the IAM identity that you've associated with the instance, and it'll inherit those permissions. It gets that token, passes that token onto the Kubernetes API. The other side of the little authentication plugin lives on the kubelets and on the Kubernetes backend, and that'll then go and do another request to STS to verify that you are who you say you are. So that gives us a native experience. It's the same thing for machines and humans, and it's only handling one component of it. So, Kubernetes has a very powerful role-based access control systems, and we're not replacing that. We're not using IAM to define what permissions you have when you access the cluster. We're just using it to prove you are who you say you are. So, kind of break it down. Step one, your CLI is passing your AWS identities to the Kubernetes API. Kubernetes API reaches out to STS, verifies that you are who you say you are, then goes and queries against the role-based access control in Kubernetes saying, this entity, what permissions does it have to the cluster? And then either allowed or denied will be returned back to the user. So, as I said, we've got a couple of ways that you can go, that you can build a worker node. Doing it by hand is entirely possible. The Packer scripts that we provide are on GitHub that build the worker nodes, and they're fairly simple. I think it's about 100 lines of shell script, and it's just fetching the few binaries that are needed, doing a little bit of configuration in terms of what version of Docker to set up and that kind of stuff. So doing it yourself is entirely possible, and if you have a look at the quick start code, we're not even baking an AMI there. We're doing it at boot. So when an instance boots, we're taking a vanilla SLES AMI, and when it boots, we're just running those configuration steps, and it takes 2 or 3 minutes for them to run completely. And the nice thing about building it yourself is if you have specific requirements that you can bake those in. If there's any security controls you need to put onto instances, if you're using configuration management, you can build that into your Chef or Puppet stacks to get that going.
So that's open source content. Customers can go and almost reverse engineer the quick start to see how you did that?
Yes, and the Packer scripts are open source as well. So the EKS service team provides the steps that they use to bake their official AMIs are open source, and one of the inputs is AMI ID. So theoretically, you could take any AWS AMI and use that as an input to the script. In our case, when we tried it with SLES, there were a few things that we did need to tweak, though. The kind of overview of it, of the whole process of provisioning a worker. So once you've made that initial API call to create the cluster, you'll set up kubectl, the Kubernetes CLI, and the first thing that you'll need to do is you'll need to create a special configuration map in Kubernetes, and that maps an AWS IAM identity across to a RBAC role. So you say this entity is allowed to do these things in the cluster. Push that through, and once you've pushed that through, you'll provision worker nodes. Those worker nodes will be assigned an IAM role. They'll be told the endpoint of the cluster, and when they boot up, they'll attempt to connect to the cluster using that same authentication mechanism, and they'll register themselves as nodes with the cluster, assuming everything's been done correctly. So as I mentioned, all of these projects are open source. I think the slides are going to be shared, so you can take photos or wait for the slides to come out. We've got the CNI, the worker node Packer scripts, and the cloud application platform quick start. The one resource that's not here, you guys can ask me for the link afterwards if anybody's interested in it, is the actual source code for the IAM authentication plugin. And that's now owned by the CNCF as one of the Kubernetes SIGs owns that. And us and Heptio jointly lead development.
AWS Labs as well?
No, it's under the Kubernetes repo. Thank you for bearing with me, everybody. I'm going to hand back over to David.
Perfect.
All right, so as we said, the SUSE worker nodes, there are workarounds with the CloudFormation template and the Packer scripts where you can run and if you can run SLES worker nodes, for example, through the quick start. We are incorporating a lot of those packages into our modules, the appropriate modules, so that you can run this on a worker node image. And we are working with our engineering team and the AWS engineering team to publish that. And it's coming soon. I know that we'll kind of push out the messages that you know, through blog posts, tweeting, LinkedIn. So if you follow SUSE blog, the community, SUSE blogs, you'll actually see it. So we'll be pushing it out. And we're thinking maybe about 4 to 5 weeks. We wanted it to make it available, with the cloud application platform, but just as I said, we're an enterprise Linux distribution, right? And if you think about what we do and what we offer, a lot of it is offering our opinion on what packages should be included in the distribution, but also offering the support behind it. So we really didn't want to create a shortcut, launch this. We wanted to go through the appropriate channels. And why would you choose a SUSE worker node? Of course, based on just what I explained, we are an enterprise Linux distribution. We are going to accept things, packages, open source packages included within that SUSE worker node, and ensure that it follows all of our best practices. And of course, by leveraging SUSE, you can deploy not only on the public cloud, but on premise. So a lot of the skill sets that you have, a lot of the investments that you've made in learning SUSE can continue on, whether you're in the public cloud or on premise. Now, these are some of the AWS SUSE sessions that we have going on. I just wanted to highlight them. We have HPC with SLES for HPC on AWS. An application a year to an application a week on AWS, public cloud roadmap, and we have some specific AWS and SUSE SAP sessions. So if you're interested, I can share the sessions with you after we do the Q&A. So are there any questions?
Yes. What flavor of SLE are you running for worker nodes? Is that MicroOS or is that SLES?
So it's SLES. So it is SLES. We are running a SLES AMI. Cloud Application Platform.
Are there different flavors, or is it pretty much?
It's, we have different versions. Really, it's, I don't know if I should say. Are you familiar with Cloud Foundry?
A little bit.
Okay, so it's really, what we've done is containerize all of those components within Cloud Foundry. We're part of the Cloud Foundry community. We don't necessarily, it is a cloud native development platform. It goes beyond just Cloud Foundry, but essentially that's what it is. And it allows developers to have that like CF push capability into a Kubernetes platform, where originally Cloud Foundry leveraged Diego for the orchestration of the different services and components. And now what we've done is we've worked with the Cloud Foundry in bringing Kubernetes as that orchestration along with a few other partners. So the question is, once we deploy SUSE on the quick start, I should probably be repeating the questions. Are they certified or hardened? I think that's where we're waiting. We're actually working with AWS to publish that certified worker node. So if it is escalated through AWS, we are going to be that certified AMI to run as a worker node. So that's really what we're doing. That's why we could announce it, that hey, you can run SUSE on as a worker node on EKS, but we're really trying to do right by our customers and our partners.
It's so the question was, and correct me if I don't get it right, the IAM integration, is there any additional components to that above and beyond the vanilla IAM out of the box? And it is entirely out of the box IAM authentication. The authentication mechanisms that Kubernetes provides for webhook authentication, which is one of the kinds of authentication, turned out to be exactly mechanisms that are in use in native IAM. So the two just work together out of the box pretty well.
So no need to customize anything.
Right, yeah, and one of the big benefits is you don't need to now, especially for things like compliance, you don't need to have a whole second set of credentials and that you're maintaining. You can control that in one place.
Any other questions? All right, thank you.
Thanks a lot, everyone.